Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So today problem again mechanics, kinematics and again acceleration. One body moves with a constant speed, another with acceleration. So what's going on? So we have this point A, and at the initial moment of time, the car and the bicycle both located at that point. Only the bicycle moves with a constant speed from here, and at 0 time with the speed v0 it is here, and the car starts its movement from that point. And so the car goes faster, 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 and the bicycle first goes faster than the car, so it goes faster than that, but then at a certain moment the car starts to catch him up, and at a certain moment they are at the same distance, and at that moment the bicycle still moves with v0. The car obviously moves faster, because at that particular moment it has to have higher speed because it's coming from the back and it catches up with the bicycle, so in order to catch up it has to have higher speed. And the question is how much higher speed would be at that particular moment. And again, let's solve like previous time the problem. Let's solve it with formulas first. Good time to pause, look how we solved the previous problem with the video, and then let's continue. So basically this is the distance when they meet. So let's write this distance in two different ways. The first way for the bicycle. Bicycle moves d equal v0t, and t would be the same time for the bicycle and for the car. So d equals vt, this is the bicycle. Now what about the car? For the car, remember, it's accelerated movement. If we move with acceleration, those two formulas that we need to remember. This is easy to remember. It's v minus v0 equals a divided over t. So this form, or a equals delta v over delta t. And this is the distance. Distance is v0t plus at squared. You can derive it. Please go to videos back, pause it, go back, see how I derived it. Or you can memorize it, or you can remember, or you can simply use it, and by using it you will remember. But anyway, let's use it here. So this distance covered by the car. Axis is this way, A is this way, and v0 for the car is 0. The car, as I said, starts from the rest. D equals 0 multiply t plus acceleration the same way as all the speeds to the right. So it would be at squared. And they're asking us about this v, how much more v than v0. So we have to use this formula. V equals v0 equals 0, because we're starting with the car with the rest, plus at. And basically they ask about v and v0, how they relate. D is unknown, t is unknown, a is unknown, v is unknown, v0 is unknown. Too many unknowns, only 3 equations. But fortunately they only ask us about v over v0. So it's very simple. The first equation is v0t, let's get rid of d, let's put it here, let's simplify on our way. So we put this here, we have v0t equals 0t is 0 equals at squared over 2. Here we have v equals at. Okay? It's so simple, so let's t and t squared, let's like simplify. So t goes with this squared and it becomes v0 equals at over 2 and v stays as is, at. So two equations and they want us v over v0. Let's divide this over this. It's very simple. V over v0, I divide this over this. Equal, I divide this over this at over 2. At is gone, 2 goes up, v equals 2. That means that the moment the car catches with the bicycle, its speed is twice as big as the speed of the bicycle, because bicycle moves with a constant speed. That's very nice, but let's do the same with the graph. First of all, they ask us to do with the graph, and secondly, who are they? It's me, because that's me who, who put this program. But for you, it's they. So they ask to do it graphically too, and even if they wouldn't, I suggest you do, because this will give you a way better understanding of what is going on. Okay, graph, and of course we will graph v over t, because v is changing, at least for the car. So, v over t. So, this is v0, and this is how the bicycle moves, with a constant speed. And this is the moment when they meet, right? And the car, it starts with zero initial speed, so v equal at. We already wrote it, so t equals 0, v0 equals 0, it starts here with 0 speed. And then it's a straight line. So, pause and draw this line, because you have many options. You can draw it like this, you can draw it like this, or you can draw it like this. Different angle, defined by acceleration, tangent, this angle, tangent of the slope is equal to a. So now you have to pause and find out what would be the graph. And now I will explain that the graph would be like that. And why is that? And that's because this area is d, because this is the distance that bicycle covers, and it's exactly the same like this area, the area under this triangle. So those two areas are the same, and the only way to do this is if this area equals this area, if this equals this, because just looking on those triangles we can say this should be equal to this and this should be equal to that. Basic geometry. And that means that this is v0 and this is v0, and that means that the speed v attained by the car should be double v. Again, graphical solution, simple, and it shows that first the speed of the car is less than the bicycle, so the bicycle will be moving far and further away. At a certain point, the speed of the bicycle and the car would be the same. So if we're sitting in the car, we will see that bicycle disappears somewhere close to the horizon, but as we gain the speed at a certain point, the distance is the same, and starting this moment the speed of the bicycle is less than the speed of the car, so the car is catching up, and finally at that moment they cover the same distance and they are at the same spot. Of course they should avoid the collision, but it's obvious. But at that point car is already zooming with twice as speed passing the bike. So please subscribe, please bell, please like, please put your comments, please put your questions, please put your problems. I try to solve them if they are interesting. Thank you very much. See you next time.